Welcome back. This is Mr. Hassan's Maths channel. I'm now answering question number 2 from the May-June 2023 9709 paper 1 variant 3. This is from the Pure Mathematics Cambridge A-level papers. It says the function f is defined for x is an element of all real numbers by f of x equals x squared minus 6x plus c, where c is a constant. It is given that f of x is greater than 2 for all values of x. Find the set of possible values of c. All right, so there's a number of ways we can tackle a question like this. Now, what we see here is its domain is all real numbers, so we don't have to worry about any restrictions to the domain. And we can see here and that its range is greater than 2. So a quadratic function here, we can see the coefficient of x squared is positive, so it's going to have this type of shape. So it's going to have a minimum point below which it never goes. So because it's a quadratic, we can find the minimum point in different ways. Now, one way we can find the minimum point is by completing the square. If we write this in the format where we have completed the square, that will help us give the coordinates of the vertex, which will tell us the coordinates of the minimum point. So over here, if we complete the square for this, we have x minus 3. We take half of the coefficient of this and we square that bracket. That's x minus 3 squared. Now that's going to give me x squared minus 6x plus 9. We don't have a plus 9, so we're going to take away 9. And then we got plus c. So the vertex of this, the coordinates of its lowest point, are going to be the x value that makes this bracket 0, which is 3. And what will be left outside the bracket will be this, which is, we can write this as c minus 9. Minus 9 plus c, same as c minus 9. So this tells you the minimum y value. The minimum y value, this is the lowest it ever gets on the y. Okay? So that means if f of x has to be greater than 2, this stands for the y value. That means the y value has to be greater than 2. So the lowest y value, c minus 9, the lowest y value that exists on this graph has to be greater than 2. Therefore, c must be greater than 11. When c is greater than 11, then this will be greater than 2 for all values of x. Okay, because all the other values of x will give you values which are going to be, greater than 2. Okay, c equals 11 will give you a value that's equal to 2. So if c is greater than 11, then y will be greater than 2. The range will be greater than 2. So there's the answer to this question. I would leave it like that. That's how I would answer this question. I think that's the easiest way to do it. But the student who asked me about this question, he said, can you show all the different ways of answering this question? Okay, now the other way in the that you could use, and a way that would be a general way of answering it if you didn't know the shape of the graph, okay, or it wasn't a quadratic graph, for example, then you could use the gradient function, because at the vertex, at the lowest point, at the minimum, we can see that the gradient is equal to 0. At this point, the gradient is equal to 0. If you drew a tangent here, the gradient would be 0. So we can take the function f of x equals x squared minus 6x plus c, and we could find the gradient function by differentiating this. That gives us 2x minus 6. And we know that at the turning point, where it's going to be the minimum or the maximum, in this case it's going to be a minimum, as we can see is a quadratic. Okay, at the minimum point, we can see that the gradient is equal to 0. F dash of x is equal to 0. So 2x minus 6 is equal to 0, in which case 2x equals 6 and x equals 3. So when x equals 3, we can find what y is. That's going to be 3 squared minus 6 times 3 plus c. That's going to give you 9 minus 18 plus c. So you end up with c minus 9. Okay, so we can say that c minus 9, the lowest value has to be greater than 2. So c has to be greater than 11. So it's finding the vertex. Okay, it's finding the vertex, but by using differentiation to find the turning point, and then put that x value of the turning point back into the equation. It will tell you the y value of the turning point. So it's a similar kind of process to this, except we did this by completing the square because it's a quadratic. This would be a general way to find the minimum point if it was not a quadratic. Okay, you might have to justify that it's a minimum by taking the second differential. In this case, you just get 2, so you know that there's only one turning point, which is a minimum. Okay, because the second differential is less than 0. Okay, so there's no numbers to put in here because it just has one turning point, which is a minimum, as we can see from the fact that it's got a positive x squared. That's the second way of answering the question. All right, so now a third way of answering this question would be to find out when x squared minus 6x plus c is equal to 2. X squared plus 6x plus c, or x squared minus 6x plus c, sorry. X squared minus 6x plus c. We could find when it's equal to 2. And in this case, it would be when y equals 2 is a tangent to this curve. Y equals 2 is a tangent to this curve. So we find the values of c such that y equals 2 is a tangent to this curve. Or we could say such, yeah, so we could work that out, and that will also tell us the place where it reaches its minimum value, because y equals 2 is a horizontal line. Okay, so we want to find the value of c such that this will be a tangent to this curve. So when we solve this equation, we will only get one solution. So we have x squared minus 6x plus c minus 2 equals 0. Now, if y equals 2 is a tangent, therefore b squared minus 4ac, the discriminant, has to be equal to 0. Okay, so in this case, you got a equals 1, b equals negative 6, and c equals c minus 2. Okay, the c here is not the same as c there. So b squared minus 4ac has to equal 0. So b squared, you're going to have minus 6 squared minus 4 times 1 times c minus 2 has to equal 0. Okay, so we're going to have 36 minus 4c plus 8 equals 0. So we end up with 36 plus 4, which is 44, minus 4c is equal to 0. So you can say 4c is equal to 44, so c equals 11. All right, so for y equals 2 to be a tangent to the curve, c has to be equal to 11. So that means c must be greater than 11. Okay, if y has to be greater than 2, okay, then c has to be greater than 11. Okay, so we find the value of c where this will be a tangent to the curve. So we want to find the values of c for which this is going to be higher than that. So it's when c is greater than 11. And so there's the answer to this question in a third way. Personally, I much prefer, I think the first way that I've showed is the simplest way, and I would just stick to that. But these are alternative ways of answering this question, because this is a quadratic and this also leads to a quadratic equation. You can use the discriminant here. You can well, for this one, because it's a quadratic, we can use this. Okay, so these two can be used because they're quadratic equations, and you can deal with that quite easily. Number 2 can be used it's like a general method that could be used for any type of equation, whether it's quadratic or not. So that's a general way of doing it. But if you notice a quadratic, the vertex is a nice way of answering the question. So there's the answer to number 2 from this paper. Other questions from this paper can be found in the playlist that will appear in this section over here. Other questions from the topic of, I guess this is quadratics, can be found in the playlist that will appear in this section over here. You can subscribe to my channel by clicking on this link, and you can watch a video here which will tell you how to use my channel to find what you're looking for. Thank you for watching, and see you soon.